In first grade, students make one of their first big jumps in thinking about addition and opportunities for reasoning about addition when they transition from working with numbers in kindergarten just within 10. Early in first grade, they start working with numbers within 20. But then also in first grade, they begin exploring with addition with numbers with sums within 100. So the range makes quite a big jump. At first, students are going to have some opportunities, or students need opportunities to sort of play with manipulatives and some very concrete ways to look at examples like 43 plus 25, where they might take base 10 rods and units and have to represent 43, they would have 4 rods and 3 units. To represent 25, they would have 2 rods and 5 units, and then combining those together to see that now we have 6 rods and we have 8 units. And so 43 and 25, 60 and 8 make 68. And then other opportunities to maybe draw what those look like. But as they begin to work out of some concrete stages with manipulatives or one-to-one drawings of those manipulatives, they start to really think about the reasoning that they are doing when they are working with those manipulatives, and sort of decomposing those numbers into their tens and ones, and some reasoning strategies that we can use for that, and some representations that we can use to show that thinking, that begin to help students be a little bit more efficient in that representation phase as they're reasoning with addition within 100 in first grade. And so this splitting strategy, and also we could even call the model a splitting model as well, looks a little something like this. So to take 43 plus 25, we'll kind of rewrite that out. But to think of 43 and 25, we actually want to split them apart into their tens and ones, and we want to think of 40 and 3. And then to think of 25, we're going to split it into its tens and ones. We're going to think of 20, and we're going to think of 5. And so this model is a way to represent that thinking, that reasoning of splitting those apart into their tens and ones. Now, to put it back together, we'll put our tens with our tens and our ones with our ones, so we could show that 40 and 20 make 60, just like we could do visually or concretely with manipulatives. And then we'll combine our ones, our 3, and our 5 is 8. And so now we're just going to add 60 and 8. What is 60 and 8? It's 68. I love it in math when the question is also the answer. What is 60 and 8? It's 68. So I've got another example here. This one I intentionally chose these 2 examples to kind of show 2 different things that might happen. In this first example, there was no, if we were working with, say, a traditional algorithm we might call regrouping, there was no regrouping necessary here. When we combined our ones, it was less than 10, and so then we just added 60 and 8 together and got 68. In this second example, in the ones, 5 and 7 are more than 10. And so when we get to that point in this strategy and this reasoning and the way we're going to model it, we have a couple options there. So 65 and 27, 65 plus 27, we'll start the same way. We'll split them, 60 and 5, 20, or I'm sorry, this should be a 7, 27, 60 and 5, 20 and 7. We'll combine our tens, 60 and 20 gives us 80. We'll combine our ones, 5 and 7 give us 12. And so we can still add 80 plus 12 here, that's not a problem, but we might need to go a step further for some students, where 60 and 8, we just kind of say 60 and 8 is 68, that makes sense. 80 and 12 isn't 80, 12. We have more than 10 ones here. So we have a couple of options. We could break this apart again, say 10 and 2, combine our tens, 80 and 10 gives us 90, and then we could combine the 90 and the 2. What is 90 and 2? 90 and 2 gives us 92. Or some students might be comfortable just with adding 80 and 12 and knowing that 80 plus 12 is 92. So that extra step of splitting, if we end up with more tens or more ones than we can have in one place value, we can continue to split until we have just enough tens and ones that every place value could hold that amount. And so this is a way that students can start representing some reasoning in a little more sophisticated, a little more efficient way as they're exploring with addition within 100 in first grade.